Okay, hopefully you have completed the exploration and discovered some of the steps to write explicit function for quadratic functions. So the following video will include your notes for today. So example 1, we're going to write an explicit function for the following table. So the first thing we need to do is we need to be able to identify what type of function that is. So we're going to go and we are going to create some more columns to calculate the first difference. When we calculate the first difference, we notice that it's not constant. So we're going to go ahead and calculate the second difference. And as you can see, the second difference is 2. So we say that this is a quadratic function because it has a constant second difference. And if you can actually plot these points, and it's going to form a graph that is called the parabola. Okay, next we need to identify the different key features, and there are 3 things that we need to identify. And we're going to call them A, B, C for now. Okay, so A, do you remember where the A value come from? Hopefully you say, oh, A comes from the second difference dividing by 2. Okay, so A is half of the second difference. So because our second difference is 2, half of 2 is 1. So our A is 1. Okay, so here we go ahead and substitute A with 1. Now we need to find B and C. And then do you recall where does C come from? Okay, hopefully you say that, oh, well, C is just like the linear and the exponential. It is your y-intercept. So C again is your y-intercept or your output when x is equal to 0. Okay, so now we can go ahead and fill in the different pieces. We have A, which is half of the second difference. C, which is 9. Remember, that is your y-intercept when x is equal to 0. So now we're almost done. We need to find B. Okay, so B, it is the toughest one to find. And to find B, we are going to substitute any point x, y from our table, and then we're going to use reverse operations to solve for B. Okay, so I usually pick the point 116 because it's really easy to solve for 1b. Okay, so here f of x, when you substitute 1, okay, which is your output, which is 16, and then x, we're going to substitute it with 1. So we have 16 is equal to 1 times 1 squared plus b times 1 plus 9. Okay, 1 squared, that's 1. Okay, so remember to use your order operations. So 16 plus 1, 16 is equal to 1 plus b times 1 plus 9. We're going to combine like terms. 1 plus 9 is 10. So we have 16 is equal to 10 plus b times 1, which is 1b. Then we need to subtract 10 from both sides. So then that will give us 6 for b. And that is how we find b. Okay, so therefore our explicit quadratic function is 1x squared plus 6x plus 9. Okay, and just to recap, 1, okay, that is our A value, and we find that by taking half of our second difference. Next, we find C. C is your y-intercept or your output when x is equal to 0. And then we pick any point from the table into our function to solve for B. And it is easier to pick the point 116. And that is how we write the explicit function for the quadratic. Okay, for the next one, I'm going to have you try on your own. And you can do this on a whiteboard or on a piece of paper or in your notebook. And I want you to pause the video before you go on to check in your answers. So look at this table right here. First, fill out the difference table. Okay, pause the video, and then whenever you're ready to check your answer, you can hit play. Okay, so to complete the difference table, we're going to start with the last output. We're going to take negative 68 minus negative 41. And just go ahead and use your calculator so that you don't make any arithmetic error. You get negative 27. And then we take negative 41 minus negative 20. That's going to give us negative 21. Then negative 20 minus negative 5. That's going to give you negative 15. And finally, negative 5 minus 4, that's going to give you negative 9. And you should recognize that, oh, the first difference is not constant, so there's a possibility that this is going to be a quadratic function. So we go on and make a second difference. So we take negative 27 minus negative 21, that gives us negative 6, and so on, until we see that the second difference is negative 6. Now that you have found the second difference, identify your A value. Pause the video, and then you can hit play when you're ready to check your answer. To find the A value, we take our second difference and divide it by 2. So in this case, negative 6 divided by 2 is going to give us negative 3. So therefore, the A value is negative 3. Next, what is your C value? Again, pause the video, okay, and hit play when you're ready to check your answer. C in this case is 4 because that is your y-intercept, and we identify the y-intercept by finding when x is equal to 0, and then that's going to give us the output or our y-intercept. Finally, and this is the longest part, finding the B value. Pause the video so that you can try on your own, and then you can play it when you to check your answer. Okay, so here I'm going to kind of walk through the steps on how to write or find the value for B. We have identified our A, so we substitute it into our general form, and then we found C to be 4. Okay, so remember the quadratic function is f of x is equal to 8x squared plus bx plus c. Now, we are going to pick 1, negative 5 to substitute it into our function to solve for b. So our output is negative 5, and then everywhere we see x, we're going to substitute it 1. And then we're just going to use order operations. So here, 1 squared is 1. 1 times negative 3 is negative 3. Bring b down, bring 4 down. Combine like terms, negative 3 plus 4 is 1. And then we're going to subtract 1 from both sides, giving us b is equal to negative 6. Finally, we can put all that together to write our quadratic function. F of x is equal to negative 3x squared minus 6x plus 4. And don't be too confident. We want to make sure that our quadratic function works. So we're going to substitute one point, any point, and I'm going to substitute 2 in for x. And when we do this, hopefully we will get negative 20 out. And that is the case. So we have correctly written the quadratic function for this table.